So basically, we've known the equation for what? For a simple harmonic motion. Now let's talk about those systems that undergo what? Simple harmonic motion. Now the first one which we talk about is what we call the simple pendulum. The simple pendulum. The second one is what we consider to be what? The torsional what? The torsional what? Pendulum. The torsional pendulum. And the last one, which we consider, is what we call the mass spring system. The mass spring system. Though there are other examples of systems that what undergo what simple harmonic motion. But the most important are these what? Are these three. So the first one is what? The simple pendulum. The second one is the torsional pendulum. And the last one, which we consider is what? The mass spring system. Now let's talk about the simple pendulum. Simple pendulum. The simple pendulum is an example of what? A system that undergoes what? Simple harmonic motion. Now when we are talking about the simple pendulum, which is what we have here, this is the pendulum here. The pendulum is tied to a rope. And that rope is connected to what? To the ceiling. Now, when you apply a force, the pendulum will displace to a particular extent where it will now come back to what? Its initial position, which was what? When it was at what? At equilibrium. So basically, what we are seeing here, when we see a triangle of this nature, this is particularly what? A right angle triangle. What should come to our mind is what? Sokatua. This is basically what? Sine. This is what? Cos. And this is what? Sine. Now, for what we have here, if we want to reduce the triangle here, this is basically what? Our opposite. From our elementary maths 1 to 4. This is your what? Your opposite. This is your what? Your hypotenuse, because it is the longest side of the triangle. And the last side of the triangle is called your adjacent. Now, the two basic parameters which we are seeing is your what? The length and what? And the displacement. The length, which is what? L, and what? Displacement. So what are we basically using here? We are basically using what? Sine theta. Sine what? Sine theta. So basically, your sine theta is what? Opposite divided by what? Your hypotenuse. Opposite divided by what? Your hypotenuse. So basically, what we have here is what? Sine theta is equal to x over L. Now, this is when we are considering the triangle. Now, what if we are not considering the experiment itself when we are talking about sine theta? Now, when we are considering the experiment, then basically we are considering the force in which was applied, the force that was applied to move the pendulum to this certain displacement. When we are considering the experiment, we are considering the force that was applied to move your pendulum to this particular displacement. And when applying that force, what happens? The pendulum ball is acting what? Downward. It's acting what? Downward. That's why we have the downward arrow here. And the downward arrow here is what? Mass times what? Gravity. And when we are talking about the product of mass and gravity, then we are referring to what? Weight. So basically, when we are talking about the experiment, your sine theta is basically what? The force which was applied to move this displacement, to move this pendulum with this particular displacement, divided by what do we have here? The weight of the of the pendulum, divided by the weight of the pendulum. Now, we can say this is over 1 and we cross multiply. Now, if we cross multiply, what we have here is basically what? W sine theta is equal to what? Force. W sine what? W sine theta is equal to what? Force. Now, we can still rewrite this to be F is equal to W sine what? Theta. F is equal to W sine theta. Now, remember, I told you that your force is the same thing as the product of what? Mass and acceleration. So basically, MA is equal to what? W sine theta. Recall, from what we have here, we saw that the pendulum is acting what? Downward. It's acting what? Downward. So we have what? A negative sign here. Also, I told you that weight has two products. Weight has what? Two parameters. And what are they? Mass and gravity. So basically, your MA is equal to minus mg multiplied by what? Sine theta. Are we together? We have a minus sign here. Minus sign crossing an equality sign. It is what? A positive sign. So basically, this is what? MA plus mg sine what? Theta equal to what? 0. Remember, this is acceleration. And I told you that when we are talking about acceleration, acceleration will give us what? The second differential of what? Velocity. So basically, your A can be written as d square s over what? dt square. Apply this concept back to what we have here. We simply have that our m d square s over what? dt square plus mg sine what? Theta equal to what? 0. Now, I told you that when we have a second differential here, we also make that second differential to stand on its own. Now, if you want your second differential to stand on its own, what do? You divide through by the parameter what? M. Now, if you divide through, divide what? 2 by M. Now, if you do that, you simply have your m d square s over dt square plus mg sine theta is equal to 0. This is dividing what? M. This is dividing what? M. And this is dividing what? M. Now, M will simply cancel out M here. Your M will simply cancel out this M. And 0 divided by M is the same thing as what? 0. So basically, we have d square x over what? dt square plus g sine theta equal to 0. Are we done? No. Remember, I told you that when we are considering the triangle, which is what? Sine theta. I told you your sine theta is what? Your sine theta is simply what? S over L. Your sine theta is simply what? S over L. So what is S over L? S over L is basically, recall that sine theta is equal to what? S over L. So we are inputting x over L with sine theta. If you do that, you simply have d square x over what? dt square plus g multiplied by x over L is equal to what? 0. Now this can also be written as d square x over dt square plus g over L multiplied by what? X is equal to what? 0. Now we are seeing that we are now having a similar equation with what? Our equation for SHM, which is what? The equation for simple harmonic motion. Now, since we have the equation for simple harmonic motion, the next thing we do is, when we are calculating for the equation for simple harmonic motion, I told you that we represent your gravity over what? Of the length, the gravity and the length of the pendulum here with what? Angular velocity. So basically, we can say that what? W square is equal to G over L. Now, if you represent this to be G over L, we simply have that d square S over what? dt square plus G over L, we have W square. W square multiplied by what? S, and this is equal to what we are saying. So basically, this is the same equation with our what? SHM. That is why we said what? Your simple pendulum is an example of what? A simple harmonic motion.